You know what time it is. It's news time. Hi everybody. Today I want to talk to you about a type of graph, a way of representing data that's called a box plot. Sometimes they're called box and whisker diagrams, but I'm going to refer to them as box plots. They are small, simple graphs that are really quick to draw and easy to understand, but they have a little bit of work to do in order to draw them. You can see here in front of me there are two box plots. This is what they look like. They have 5 vertical lines each and a box in the middle. That's why they're called box plots, because they've got a box. And these 5 lines represent specific things. The ones at either end, at the beginning and the end of them, are the smallest number in a set of data and the largest number in a set of data. The line in the middle is the median value, or the average value, the number in the middle. These two are the upper and lower quartiles. The lower quartile comes first, just after the minimum, and the upper quartile is just before the maximum. So in between here, this box goes from the lower quartile to the upper quartile, and the distance between them represents the interquartile range. So the box itself is, the width of it is the interquartile range for that set of data. Let me talk a little bit more about those in a second. What I've got here is a scale for these two box plots. This is the length of 2 different types of animals. I've been going around collecting animals and measuring them and then putting them back. And I've been looking at lizards and salamanders. You get loads of these in the local area where I live. And the lizards are quite small and the salamanders are a bit bigger. And I've drawn a box plot for each of them. And the first thing you can do once you have box plots, and it's especially useful if you have more than one of them, is to compare the differences. So the salamanders and the lizards, the median value, which is in the middle, that one there is lower down on my scale. So that means the lizards, the median is smaller, and the salamanders, the median is bigger. So on average, the length of the salamanders is bigger. So these are bigger animals. The box itself, the interquartile range, measures the variation in the data, how different the numbers are from each other. So the lizards have a bigger interquartile range, and the salamanders have a smaller interquartile range, which means there is more variation in the lizards. The range itself, the entire range, is from the smallest to the highest number. It's much, much bigger than the lizards. But the interquartile range is a bit more sophisticated. It tells you the difference between the lower quartile and the upper quartile. It ignores the really big numbers and the really small numbers, and it gives you a measure of the spread of the average half of the data. This represents half the data in the middle, and if it's far apart, like in the lizards, that means the lizards, the average half of the lizards in the middle, they're very different from each other. Whereas the salamanders, they are very close together, so the interquartile range is smaller, which means the salamanders are more similar to each other. They're not exactly the same size, but the middle half of the data is closer to the median, and therefore this group of animals here are more like each other, whereas this group of animals here are more unlike each other. We say this has more variation, and we say this data is more consistent. And the box plots themselves are quite quick to draw, and I'm going to show you how. We can do this in 2 different ways. We can do it from a cumulative frequency diagram, which we're going to look at later. But just initially, you can just find these 5 numbers from a set of data, a list of numbers, and then you can draw the box plots really quickly. So what I've got here is some data from you. I've got your names as well as everybody in grade 10 actually. And what I've done is I've just counted up how many letters there are in everybody's names. And what I'm going to do is I'm going to draw a box plot for everybody in grade 10 to have a look at the spread of the data. In order to do this, what I need to do is to write out the numbers I've got in my data. So all of these lengths down here, I want to put them in order. So let's just quickly do that. Try and do that fast. I'll speed this bit up. And once I've got the data in order, I think I've got everybody there, I can find out the median value. I need the lowest number, which is obvious, the highest number, which is 24, and then the median value and the lower quartile and the upper quartile. The median is quick to find, so just cross off lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. So the number in the middle is 13. That's Arthur's name. That's the median value. This has an odd number of things, so I'm going to find the lower quartile by looking at the median of the lower half of the data. I'm not going to include the 13, I'm just going to look at the lower half of the numbers. If there were 2 numbers in the middle, I would include one of them in the lower half, but if there's an odd number of numbers, you don't include that, you just focus on the lower half. I've got 1, 2, 3, 4, 5 numbers here. Lowest, highest, lowest, highest. So that means the lower quartile is 10. For the numbers at the top, I've got another 5 numbers here, so the lowest, highest, lowest, highest. The upper quartile is 18. So the minimum is 9. The lower quartile is 10. The median is 13. The upper quartile is 18. And the maximum is 24. And I can use this to draw a box plot. I've also got data here for people in grade 9, and I did this earlier, and I can quickly do the same for this one. And when you're doing this, you need to have a scale. It's really important to have a scale. You can't just throw your box plot down anywhere. You have to have a number line which the box plot sits on top of. So I need numbers between 9 and 22, because the lowest possible number in my set of data is 9, and the highest one, which was, we had 22, that was Delia, had 22 letters in her name. So I'm going to use a scale of 1 centimetre per letter. So now I can compare the difference between the grade 9 names and the grade 10 names. It's actually, the longest name is Carolina, that's 24 over here. So the grade 10 has the longest name. Both have names which are 9 letters long. That's Angelina actually. And there's also Sky and there's Amy in grade 9. But so the range for grade 10 is bigger, and the interquartile range is also bigger. The width of this box shows that there is more variation. It's not radically different from grade 9, but it is definitely wider. So that means there are more different names. There's more variation in the data for grade 10 names, and for grade 9, the names are more similar to each other. I mean, they're not exactly the same, but there is more variation in grade 10. And this box is really easy to compare. Once you've drawn the graphs, you can look at the difference between them. Now, the other thing to note, as well as the variation, is the difference between the medians. The median for grade 10 is lower at 13, and the median for grade 9 is 14. Now, they're not far apart, 1 letter difference, but you can say, on average, the grade 9 names are longer because the median is higher. Whenever you have box plots, and in fact, whenever you have data in general, if you have a histogram or a cumulative frequency diagram or a box plot, we're looking at 2 things: the averages, the difference between the averages, and the difference between the variations. And both of these 2 are really useful to compare. The grade 10s are more varied, but on average the names are shorter. The grade 9 names are more consistent, but on average the names are longer. And box plots are really easy to read once you know what they represent. They have 5 lines. And when you draw them, it's best to draw the 5 lines first. Then you put a line going up to the box. You draw a box around the middle 3 lines and a line going across there. You don't draw a line in the middle here. You don't need to. It's best to leave that box nice and blank. But you draw the 5 lines, you draw around the box and connect up the whiskers, we call these at the end. And they're dead easy. And I'm going to ask you to do some practice. Good luck.